The starting point of the company's research activities is the Advanced Planning Group, a body concerned with visualizing and developing entirely new concepts and providing a fundamental advance guard for the individual research departments of the various divisions. The research and development facilities of the Aero Engine Division are among the most modern and extensive of their kind, and a large part of the test equipment is designed by the company in order to meet its particularly exacting standards.
The next test will be an acceleration in 20 seconds from ground idling to takeoff. Please call engine speeds every 500 LP RPM. Are you ready?
Yes.
3, 2, 1, 0. 7,000, 7,500, 12,000, 12,500, 13,000.
At the Flight Development Establishment at Hucknall, engines are constantly being flight tested, from improvements in current production models to highly secret research projects. For this purpose, a number of aircraft have been converted into flying test beds, so that all types of engines can be installed and tested under actual flight conditions. Ever since the development of the turbojet made jet-lift vertical takeoff practicable, Rolls-Royce has been a pioneer and world leader in this field. This is the Short SC-1, an experimental aircraft built by Short Brothers and Holland for investigating vertical takeoff and landing. The SC-1, which was the first true vertical takeoff aircraft to achieve transitional flight, is powered by 5 of the company's RB-108 engines. 4 for takeoff and landing, and 1 for conventional flight. The French Dassault Balzac VTOL research aircraft is powered in vertical flight by 8 RB-108 lift jets. The Balzac is a forerunner of the Mirage 3V, which obtains its VTOL capability from 8 RB-162 lift jets. The German VJ-101C is a supersonic aircraft powered by 6 RB-145 turbojets. 2 of these engines are mounted vertically in the fuselage. The other 4 engines are mounted in swiveling wingtip pods, which remain upright on takeoff and landing. The aircraft uses all 6 engines for jet lift, but for conventional forward flight, the wingtip pods are swiveled to the horizontal position to provide propulsive thrust. Rolls-Royce's latest lift jet, the RB-162, gives a thrust of 16 times its weight. It has been chosen for all the new vertical and short takeoff strike and transport aircraft being produced in continental Europe. The French Mirage 3V, the German Donnier 31 and VAC 191B, as well as other V-style projects. Rolls-Royce and Associates is responsible for supplying the nuclear steam raising plant for Britain's nuclear submarine program. HMS Dreadnought was the first to be so equipped and is being followed by additional nuclear-powered attack and missile-launching submarines. This company, based at Derby, also operates a nuclear research reactor, Neptune, on behalf of the Navy Department. Rocket propulsion is another facet of the manifold activities of the company. Based on designs from the Rocketdyne division of North American Aviation, the company has developed its RZ2 rocket engine, which has a thrust of over 65 tons. Two of these rocket engines power the Siddely Blue Streak, first stage of the satellite launcher being produced for the European Launcher Development Organization. the first launch of Blue Streak was made from Woomera in Australia in June 1964. Engines produced by the Oil Engine Division undergo the same painstaking research and development, as in this example, where an engine is being subjected for night after night to 29 degrees centigrade below zero, in order to confirm that it will start with ease every morning. Similar tests are applied to the commercial and military range of petrol engines in an endless search for improved performance and greater reliability. This test is intended to confirm the ability of petrol engine vehicles to wade in up to 6 feet of water. Development testing of these famous British cars is legendary. This lock-to-lock rig was designed by the company's engineers to test the hydraulics of the power-assisted steering fitted to all cars made at Crewe. Constant inspection and testing is the guiding principle of the motor car division as much today as it was in the time of its creator, Sir Henry Royce. As a result of rigorous development testing all over Europe, such is the traditional reliability of these cars that little beyond routine servicing is required. Worldwide networks of after-sales service facilities and spare parts depots are organized by each of the divisions. Service engineers advise customers on maintenance, overhaul and all operating matters, and provide on-the-spot services wherever the company's products are in use. In the Aero Engine Division alone, over 200 service engineers in some 30 countries are engaged in this work. First-hand reports on product performance under all operating conditions are constantly fed back by these engineers, thus ensuring continuity in the company's cycle of research and development. As part of the company's extensive service facilities, the Aero Engine School at Derby provides comprehensive operating and maintenance courses for flying crews and maintenance engineers from customers' organizations. Similar training facilities are provided by the Oil Engine Division and by the Motor Car Division. Worldwide service with the personal touch is one of the vital factors that influenced over 110 airlines from all over the world to purchase Rolls Royce-powered aircraft. To maintain the company's present competitive position in the world market for aero engines, an altitude test plant for testing gas turbines under simulated flight conditions has been built at Derby. Treated air at the correct temperature and pressure conditions for any selected altitude and speed, up to 80,000 feet and over twice the speed of sound, is fed into the air intake of the test engine, while the remainder of the engine is subjected to the low pressures corresponding to the altitude. The cost of this plant was more than £6 million, entirely borne by the company. This British company's record of achievements on land, sea and in the air is unsurpassed. Its contribution to the fields of engineering, research and development is universally proclaimed. But for all that, the search for improvement goes on. An eternal quest for perfection in a range of products that provide power, economy, durability, quality, safety, and maximum reliability, backed by unrivaled worldwide service and a name that stands for the best.